So my computer died in the middle of that last video. So I'm just going to pick up here where I left off on that ambiguous cases example. So we were in the middle of, we had just found for case one, or for one of the answers, we found that B is 74.6 degrees. And then I reminded you that even though it hasn't been mentioned yet, we also have to worry about angle C and side C. So if we know that angle A is 40 degrees and angle B is 74.6, if we subtract those from 180, then we get that angle C is approximately 65.4 degrees. So we found all three angles, but we also have to find side C. So to do that, we need to do the law of sines again to find the side. So then if we use, let's say, A over the sine of A is equal to C over the sine of C, then we've got A over the sine of A will be 20 over the sine of 40 is equal to C is what we're trying to find over the sine of the angle we just calculated here is 65.4. And then to isolate C, if we multiply both sides by the sine of 65.4, then we end up with C is equal to 20 over the sine of 40 times the sine of 65.4. And again, since this is over 1, technically this is one big fraction. So in your calculator, you'll type in 20 times the sine of 65.4, all divided by the sine of 40, and you should get that side C is approximately 28.3. Okay, unfortunately, we're not done. All of that was solution 1. So this was in that first case where, because remember, this scenario had two possible solutions. Think about the two possible triangles. So this triangle is an acute triangle. So solution 1 consists of angle B, which is approximately 74.6 degrees, angle C, which was approximately 65.4 degrees, and side C, which is approximately 28.3. So that's solution 1. To find solution 2, the good news is it's not as laborious to find solution 2. So to find the second solution, basically, let's recap. Recall that the sine of a coordinate point is essentially the y value. Or the sine of an angle is essentially its y value coordinate point. So if you think about it this way, coordinates on the unit circle, where do they have the same y value? They have the same y value, or the same y coordinates in quadrants 1 and 2. Well, we just used quadrant 1 when we found that B was 74.6 degrees. So that means if the first solution for angle B is 74.6, to find the other y coordinate that has that same value, we simply need to subtract from 180. So we're going to take 180 minus 74.6 because this was the first solution for angle B. And to that, we're going to get 105.4 degrees. So both of those two angles, 74.6 and 104.5, those are in quadrant 1 and quadrant 2 respectively. Those will have the same sine value. Okay, so then this implies that angle B is approximately 105.4 degrees. And if angle B is 105.4, let me give it some more space here. Then again, we can easily find angle C by taking 180 minus 105.4 minus, remember, angle A is still 40 degrees. So this is the second solution. So that's the second angle B, and this is angle A. And then that's going to give us approximately 34.6. So then angle C is approximately 34.6. So those are the two angles, and we already have two of the sides. The only thing that we have left to find is side C. So if we do that, then we're going to set up A over the sine of A is equal to C over the sine of C with this new C degree here. So that implies that 20 over the sine of 40 is equal to C over the sine, well, let me actually put the numbers here. 20 over the sine of 40 is equal to, well, we did know that anyway, sorry, C over the sine of the angle is 34.6. I should put degrees there. And then to isolate C, we're going to multiply both sides by the sine of 34.6. And that's going to give us side C is equal to 20 times the sine of 34.6 all over the sine of 40. And if you carefully enter that into your calculator, you will get that side C as approximately 17.7. So then that implies for our second solution, solution 2, we get angle B could be the obtuse triangle option of 105.4 degrees, which it would imply angle C would be 34.6 degrees, and side C is approximately 17.7. Okay, so I know it seems like a very laborious problem, but those ambiguous cases will only come up a certain part of the time when you have two solutions, actually taking the time to go find both of those solutions. So solution 1 consists of the given information in the triangle already, which is where they gave us angle A and side B, and so we went to go find angle B and C and side C. So this was solution 1, which would create the acute angle option, and this one here is solution 2, which could create the obtuse angle option. So that's how to handle ambiguous cases using the law of sines.